Okay, in this video today we're going to talk about polynomials numerically and graphically. We're going to focus on the rational root theorem or the rational zero theorem. So we're looking for the rational, the whole number, the fractions or decimals that are terminating or repeating, answers to any type of polynomials. So we're going to start off by talking about a quartic function, so a fourth degree function. So if I look at this graph of a fourth degree function, this equation, I notice instantly leading degree is 4, so it's quartic. A value is positive, so it's a positive even function. And I should have a graph that has 3 changes in concavity. So when I think about this graphically, I know it's going to look something like that, okay, on a grid. My question that I'm asking though is if these 4 solutions or zeros or roots are going to all be rational, or if some are going to be irrational, or maybe even possibly imaginary. So we're going to use the rational root theorem to help us eliminate or to understand some of that. Now the rational root theorem simply is a fraction bar, and on your numerator of your fraction it is the factors of your constant, your last term. So in this case the factors of 1, which is just going to be 1. And then your denominator is going to be the factors of your leading coefficient. So the factors of 12, well that's 1, 2, 3, 4, 6, and 12. Okay, it's kind of like a formula, a setup process. We're going to use this plus or minus, takes care of both your signs, to generate a list. So a plus minus, then a set of numbers. It's simply a division. 1 divided by 1, 1. 1 divided by 2, so 1/2, 1/3, 1/4, 1/6, 1/12. So I have a list of 1, 2, 3, 4, 5, 6 positive and 6 negative possible solutions. Now are they guaranteed? No. But some of them could possibly be the rational solutions to this quartic function. This is pretty much what your rational root theorem does. It gives you a list of possible answers. Now, sometimes that's all your teacher would ask you to do, is to develop this list and you're finished. There are also other cases in which you want to use this list to figure out which one or ones of this root or this theorem is actually going to be an answer. So, how could I figure out or test these to see if they're actually a root of this solution? Well, let me go back and think about this numerically. Okay? If I take 1 and substitute into this equation, it's going to generate me an answer. What if I substitute in -1? It's going to generate an answer. And so if I think about what I know about a root or a zero, well, I know an x value is guaranteed to be a root or a zero if the y value happens to be a 0. So I'm simply going to go to my graphing calculator. I've already got my function typed in. I'm going to look at my graph to make sure it's the right picture. I see kind of my W. Okay, I could play with the window to get a better picture if I wanted it, but I'm not worried about the graph. I want to go to the table. So if I go second and window for table set, I want to make sure that my independent is on ask, and it is. I'm going to do second and graph for table. I'm just going to start asking the possible answers that we generated earlier. So the first one that we generated earlier was 1. And by typing in x as 1, I get a y value of 0. I know instantly that's a root. So I already have one rational root. Let's see if I have more. I'm going to test a -1. -1 is an answer. So I know -1 is a rational root. My next in my list was 1/2. So 1/2 is a root. So I've already got 3 of my 4 being rational. Let's see if I can't find the other one. Let's type in -1/2. That one's not, because it gave me a -3. So this one is not an answer, not a solution, not a 0. Let's type in, we have 1/3 was next. That one doesn't work. Try our negative version, so a -1/3. That one doesn't work. We had 1/4 was next. Not a solution. Once you get so far up on your table, by the way, it starts just changing this bottom row. That's okay, just keep going with it. -1/4, not a solution. Okay, our next one was 1/6, not a solution. Let's try -1/6. we get a solution. So again, this was a quartic function, a fourth degree function. We figured it out just by using our numerical table here, my 4 rational zeros, where x is 1, -1, 1/2, and a -1/6. Okay? Let's go back to here. Again, all those numbers were in this list. 1, -1, 1/2, and -1/6. So this rational root theorem generated possible answers. We use our table to figure out the actual answers. Okay?